Here's an example of solving a trigonometric equation by factoring. So our equation is 2 cosine squared theta plus cosine theta minus 1 equals 0. And if you sort of squint at this just right, this looks like 2u squared plus u minus 1 equals 0. And if you were going to solve this quadratic equation, you'd probably do it by factoring, or at least you could do it by factoring. And so the original equation, it also is quadratic, where the variable instead of u is cosine theta. But we can still factor it using all of our usual tricks for factoring. So we're going to need a 2 cosine theta over here, and we're going to need a cosine theta over there. We're going to need a minus 1 in one of these two spots, but if we put it in the right-hand spot, then we'd end up with a minus 2 cosine theta, and that would make this middle cosine theta negative instead of positive. So the negative 1 must go over here, and that must mean we have a plus 1 over here. And really quickly, we can check that this is right just by multiplying it out. 2 cosine theta times cosine theta is 2 cosine squared theta. 2 cosine theta times 1 is plus 2 cosine theta. Minus 1 times cosine theta is minus cosine theta. And 2 cosine theta minus cosine theta is plus cosine theta. So there's our cosine theta. And minus 1 times plus 1 is minus 1. So this factoring is correct. And since we have a 0 on the right-hand side, we can use the zero product property. So 2 cosine theta minus 1 equals 0, or cosine theta plus 1 equals 0. And now we can solve each of these independently. So for this first one, we're going to add 1 to both sides. So 2 cosine theta equals 1. And for the second one, we're going to subtract 1 from both sides. So cosine theta equals minus 1. In this first one, I guess next we divide by 2. So cosine theta equals 1/2. And nothing to do to isolate the cosine theta in the second one, so let's not mess with it. And now we need to deal with all the cosines that are lying around. So let's first find a principal solution just by taking inverse cosine. So theta is inverse cosine of 1/2 is pi over 3. But remember, we have to add 2 pi k to pick up all of the periodic solutions. Also, we have to write down the symmetric solutions. So for cosine, the symmetric solution is just the negative of the principal solution, so negative pi over 3, and of course plus 2 pi k again. All right. But this isn't all the solutions. We also have solutions coming from our second equation, cosine theta equals minus 1. So taking inverse cosines, we get theta is, inverse cosine of minus 1 is pi plus 2 pi k. And then for the symmetric solution, for cosine it's the negative of the principal solution, but negative pi is actually already in our first list of solutions, pi plus 2 pi k. Because if k is minus 1, you get pi minus 2 pi, and that's negative pi. So negative pi is already in our first list, and if we added 2 pi k, all of those would also already be in our first list. So actually, for this second equation, we don't need to write down the symmetric solutions. We already have the symmetric solutions in the first list, pretty much. So this gives us all of our solutions. It's these 3 collections of solutions. So anytime you have an equation that's quadratic in cosine or sine, you might need to solve it by factoring first and then solving each part separately.